So we have to find an infinite series solution for this differential equation. So what we are going to do is that we are going to assume this McLaurin series format for y, and then we have to talk about e to the x times y prime. So here y prime would not be hard to find, and let's just go ahead and just differentiate it from the terms here. So when we find y prime, what will happen is that a sub 0 is a constant, so we will have a1x, and I'm going to write the others and bring it back to you. So here is y prime. Then after this, you will be differentiating a2x square, a3x cube, and that will turn into this equation, y prime equals that series in terms of x, and then here we have y double prime, so a1 is a constant, so that will be 0, and here this will be 1, and this will turn into, we are not writing the coefficient as a pattern, so let's just go ahead and multiply these out as we go. Okay, so a square, and then a to the 5, a sub 5 is a constant, so here we get 20, and then we get x cubed, and here we get 30, and then get x to the power 4. Okay, so we have gotten all the important stuff here: y double prime, y and y, y prime and y, and then e to the x is it's McLaurin series. You remember this? This one is an easy to remember one. Okay, x square over factorial 2, and then x to the 3 over factorial 3. All right, and then x to the 4 over factorial 4, and the same format continues. Okay, and now after this, let me write this down. After this, it will be more like algebra 2 than any calculus in here. That is, we have this. That is what we are going to do, is that we are going to substitute all this into this equation. Okay, and then going to find the coefficients a0, a1, a2, a3, and a4, and that's what will help us get this objective that we got in the sense we are approximating the solution to a polynomial of degree 4. All right, so let's just do all that algebra quickly. So first let us just find this term, because this term is, it's an important part here. So we have, let me write this in one bracket. Okay, and then the other one is simply this one, and I'm taking only terms up to a4, and we will take up the rest as the need arises. So let's multiply these. So first I will do this, multiply this whole thing by 1. So what will that give me? That will give me simply that, right? And then when I multiply this quantity by x, what I shall get simply is, I shall get just a1x plus 2a2x square plus 3a3x cube. Okay, then 4x to the 4. All right, and then we have to we will multiply the same quantity by x square over factorial 2. And you can see I should not be rushing because I'm making mistakes here. So x to the 2. So now what I'm doing is I'm multiplying it by x square over factorial 2. So what this one will become, this part here, this would become a1 over factorial 2. All right, and sorry about doing so much. So a1 x square over factorial 2. Now 2 and factorial 2 on the bottom will cancel. So this will simply be how much? Excuse me, x cubed. All right, now we are multiplying this one by x square over factorial 2. So this will simply become 3 over 2, factorial 2 being just 2. So 3 over 2, and then here we'll get x to the 4. Okay, and then here when we come here, 4 over factorial 2 will be 2, and this would be how much? X to the power 5 then, right? And then so we got this much here, and I think this should give us, we have x cube, and x cube relates a4 to a3 and a2, and no, we should not leave this term because we will be needing the x cube term. So what we shall do is that we shall multiply this by x cube over factorial 3, and factorial 3 being 6 means x cube over 6, so this becomes a1 over 6, and then we get an x cubed here, right? And 2 over 6 is 1/3. I'm doing something slightly risky, but that's all right. So 4 here to the power 4, and then here we have 3 over 6 will be how much? 1/2, and this will become to the power 5. We don't need these terms, but I'm just writing them. It's okay, let me write them because so that we don't end up getting too big a mistake later. Okay, so anyways, so we got this as our middle term, right? So we simplified this all. Now what we have to do is that we have to collect the coefficients of everything up to x to the power 3, and we shall take these one up as the need arises later on. So we have everything in a store. If we see later on that we need them, then we will get them. So here we got a1. Now we will look at the coefficients of a. So that are, and they are going to be 2a2 plus a1, okay, 2a2 plus a1, and then we have an x here, okay, and then we have plus, what do we have then is 3a3 plus 2a2, okay, and then plus a1 over factorial 2. I could have gone to the background, but that will be slightly unfair to us because, and I'm typing. If I was writing, I would be faster, and the computer for some reason is being slow on me right now. And I'll decrease the font size just one size lower. Does not cause too much problem. Okay, and then we will get what? We will write, so we got a1, and then we got these many x's, okay, 2a2 plus a1x. Then I made a mistake, didn't I? A1 over factor, no, I did not make any mistake, so we are going good. Then we have what? So how did I get, okay, so then we have 4a4, yeah, that's what I'm missing. Okay, so we have 4a4, okay, and it's not that I'm taking long time. I mean, this computer for some reason has decided to run slow because I'm just doing too much on it. So 4a4, and then I forgot this term here. Let me not do that. Okay, so plus, okay, come back here, a2, and then we got a1 over 6, okay, x cubed. So we have gotten everything that can hopefully relate to relate a to the 4 to the lower power, so that we can write the series up to x to the power 4 term. Now, I misspoke one thing. I didn't mean a to the 4. I meant a4 to the lower indices. Now, remember this, that you have, this is our original differential equation, and this is our y double prime, right? And this is what? This is e to the x times y prime. Okay, so that's what we get. So this is the middle term, and then we have what? Simply minus y, right? So minus y is going to be the McLaurin series for y here. And now what we would do is that we shall simply combine the like powers on x. So, but before we do that, let's remember that it was minus y at the end. Remember, notice that here. So we'll change all these signs to negative. Okay, and well, we are not going to be needing these, still we are changing them to negative. All right, now let's combine the like powers on of x. So what we have first is we got 2a2, okay, plus what, plus a1 minus a0, that's our constant term, okay, and right here, okay, and then we have plus, and then we got 6a3, okay, and then we got 2a2 plus a1 for x from here. So we have, then we got plus, or rather minus, excuse me, minus this a1 and then the coefficient x, okay, and I don't know why did I ignore this sign here, okay, and then x, and then we got plus, okay, and then we will get the coefficients for x square, which will be 12a4 from here, okay, so we got 12a4, and then we got these guys from here. Let's write them down, okay, so plus all them, okay, and then we will get minus a2, okay, so a2 x square, and that equals what, that equals, I mean, this whole series equals 0. So all the individual coefficients will have to be 0. So let's see if we can relate everything. So this will be 0. Then this coefficient, and here, let's just make it lighter. These guys will cancel. So we get 6a3 plus 2a2 equals 0, right? And here, let's just make this a little better looking as well, because this is 2a2 minus a2. So then this becomes 0. So we will get the coefficients up to x4. So here what we notice is this, that our a2 will be how much? Our a2 will be 1/2, right? 1/2 a0 minus a1, or a1 minus, yeah, a0 minus a1 is okay to write. I could have written negative a1 plus a0, but this way is all right as well. And then notice this, we got this here. So when we write over here, when we write 2a2, these 1/2s will cancel. And what do we get simply? We get a0 minus a1. So in this manner, what we are able to do is that we are able to write a3 equals negative, or let's just keep it positive, 1 over 6, and we'll switch the signs there. That is negative a0 plus a1, okay? So negative a0 plus a1, okay? So this is what a3 is. And now let's come to a4 now to handle that, okay? So then for this, what we have is this, we are just simply doing simple substitutions, okay? So we have this. So we have 3a3 here. So let's substitute a3. So 3 over 6 will be what? 1/2. So we'll write 1/2 times this quantity, right? Okay, so we got that here. And then for a2, what we shall write? 1/2 times the opposite quantity looks like, right? So let's just write it, whatever it is, and then plus, plus 1/2 times the opposite quantity equals 0. And then so what does that give us is this, that notice this, these two will cancel each other, right? Because they're just opposite to each other in signs. So we have what here? We got all this with cancellations. So we get what? We get this. So A4 would be, A4 is going to be negative 1 over 24. Okay, negative 1 over 24, A1 simply. All right. So, and then if we need to go further, we can do that, or you can relate the coefficients with some extra effort, but we are not required to do that. So here, so what happens now is that that our solution y, where is y? Okay, y is right here. This is negative y. I think it'll be easier to pull up our original y instead of me going and changing the signs there. Okay, all right. So here we are. I closed some software, so this is actually going a little faster. So we have A0 plus A1x, and then we got for A2 what we got? We got that in terms of lower terms, and then for A3, where is A3? A3 is right here. So this is A3. So we have the series solution written in terms of just these two quantities, A0 and A1. So giving them different values is going to give us different series, all right, and we can go up in higher terms knowing that it is convergent. Now see, you have to extract two linearly independent solutions from this. There are a couple of ways of doing that. One is you can, or let's just do it like this, because we can just go ahead and give any values to A0 and A1 as that we would like. So let's just do this. Give A0 value 1 and A1 the value 0. Just easy quantities, okay? Or in other words, we are collecting their coefficients, okay? So if we did that, then that solution will be what? That solution will be going like, okay, with these we have A0 as 1, right? So, and A1 as 0. So let me do this. Okay. So A0 is 1, so we got 1/2 x, and A1 is 0. So this is out, and that was a 1, so that will be negative 1 over 6, and A1 is 0, so this quantity will do what? That will disappear. So this is one solution that we have, okay, that we can get. And if we switch the values, what will happen? Let's just switch these, like just give A0 value 0 and A1 the value 1. Then what happens is that I don't know why I'm copying this down, this is too big to write, but that's okay. A0 is 0 and A1 is 1. So we got this. Now A0 is 0 and A1 is 1. So we get negative 1 here. So we will have negative 1/2 x squared, and then we have A0 is 0, A1 is 1. So that simply is a 1. So another linearly independent solution is this one. So these are the two linearly independent solutions. And we can do this, we can change this to 1, or we took that as 1 already. So again, just be cautious in your algebra in here. All right.